You have been told a story about space exploration, a story of brave astronauts and powerful rockets, of human hands guiding missions across the vast, silent dark. But this story is missing its most powerful new character. You think you know how we reach for the stars, but a fundamental truth has shifted while you were looking the other way. The reality is, the silent partner in our greatest cosmic adventures is no longer just human ingenuity. It is artificial intelligence. This might sound like the beginning of a dystopian film, a future where machines take over. But I want you to see it differently. I want you to feel the incredible thrill of what this truly means for humanity. Prepare yourself to witness a new dawn in our quest to understand the universe. What you are about to discover will reshape your entire understanding of space travel. Every journey into space begins not with a launch, but with a plan. A fantastically complex plan. Mission architects must wrestle with a dizzying number of variables. They must calculate the most efficient trajectory to a distant planet. They must decide which scientific instruments to activate and when. They must choreograph a delicate dance of maneuvers months or years ahead. For decades, this was a monumental task for brilliant human minds, requiring immense effort and time. But now, artificial intelligence has entered the room. A superpowered partner that can see possibilities humans might miss. AI runs through millions of potential scenarios in the time it takes a human to drink a cup of coffee. It can simulate countless flight paths, fuel consumption models, scientific timelines to find the single most optimal combination. This is not just faster, it's fundamentally smarter. AI finds non-intuitive solutions that save huge amounts of fuel, translating into longer missions and more science. Space is unimaginably vast and unforgiving. When we send a probe to Mars, radio signals can take up to 20 minutes one way. For missions to the outer planets like Jupiter or Saturn, that delay stretches to over an hour. In that time, a catastrophic failure can occur. A fleeting scientific opportunity can be missed. A rover could drive straight into a ditch. We cannot afford to have our robotic explorers wait for instructions from a distant Earth. They need the ability to think for themselves. This is where AI grants our spacecraft the gift of autonomy. AI allows a spacecraft to become a self-reliant explorer. It can perceive its environment. It can analyze a situation. It can make an intelligent decision on its own, in real time. This is a radical departure from the old model of step-by-step commands from mission control. An AI-powered spacecraft can navigate complex environments dynamically. For example, a rover on the surface of Mars. Equipped with AI, it can use its cameras to build a three-dimensional map of the terrain in front of it. It can identify dangerous rocks. It can identify steep slopes. It can identify soft sand. Then it plots a safe path around them without human intervention. Modern space missions are data-generating machines of incredible power. A single telescope, like the James Webb Space Telescope, can produce a torrent of information so vast it would take a human lifetime to properly analyze. We are quite literally drowning in cosmic data. Images, radio signals, spectral analyses, environmental readings, pouring back to Earth from every corner of the solar system and beyond. Buried within this digital mountain are the next great discoveries. New planets, strange celestial phenomena, clues to the origin of the universe. The problem is finding them. This is perhaps AI's most profound contribution to space science. It acts as an impossibly keen-eyed and tireless assistant, capable of sifting through petabytes of data to find the proverbial needle in a haystack. AI algorithms can be trained to recognize specific patterns. For instance, in the search for exoplanets, AI can scan the light curves of millions of stars, looking for the telltale, minuscule dip in brightness that occurs when a planet passes in front of its star. This has already led to the confirmation of thousands of new worlds. Radio telescopes listen for signals from across the cosmos. Most of what they pick up is background noise, the static of the universe. But hidden within that noise could be something extraordinary, like a fast radio burst from a distant galaxy, or even, however unlikely, a signal of technological origin. AI can listen 24/7, learn what normal noise looks like, and instantly flag any signal that deviates. This lets humans focus on the most promising anomalies, accelerating the pace of discovery exponentially. AI is turning data overload into opportunity, finding patterns we didn't know to look for. We have just touched on three massive changes: smarter planning, autonomous spacecraft, accelerated discovery. Each one is a revolution in its own right. Together, they represent a complete paradigm shift in our relationship with the cosmos. It's a lot to take in, a mix of awe and a little uncertainty. This technology is moving at incredible speed, changing one of humanity's most inspiring endeavors. So let's pause for a moment and connect. This is a conversation, not a lecture. The future of space exploration belongs to all of us. Your perspective matters. If this deep dive has sparked a new idea or surprised you, let us know in the comments. Like this essay if you're excited, and comment with one new thing you've learned. Which of these three big changes, planning, autonomy, discovery, do you think will have the biggest impact? Your engagement helps shape this discussion. It tells us what resonates with you and what you want to explore next. The journey to the stars has always been a collective human dream. In this digital age, our ability to share that journey is more powerful than ever. Your voice adds to the chorus of human curiosity. Every comment, every like, is a small signal adding to the energy of this exploration, a way to participate in the story as it unfolds. Beyond the headline-grabbing roles in planning and discovery, AI is the indispensable backbone for many other critical mission functions. One of the most important is communications. Spacecraft generate far more data than they can send back to Earth. Deep space bandwidth is extremely limited. AI can help with intelligent data compression, and it does more than make files smaller. Onboard AI can prioritize data before transmission. It can analyze Martian images and pick the most scientifically valuable ones. A blurry photo of gray dust is less important than a sharp image of a strange rock formation. The AI can send high-priority data first or discard low-value files to save bandwidth. That makes our precious link to distant probes far more efficient. AI is also set to guard astronaut health on long missions to Mars. By analyzing wearable sensor data, it could track vital signs, sleep patterns, stress levels, spot early warnings, suggest diet and exercise changes, or alert to a medical emergency. AI unlocks swarm robotics, dozens of probes mapping fields, descending canyons, sharing data to build full 3D models, and if one fails, the AI redistributes tasks. Resilient, adaptable, powerful. With any technology as powerful as artificial intelligence, we must proceed with excitement, caution. It would be irresponsible to ignore the potential risks and ethical questions that arise when we hand over decision-making power to a machine millions of miles away. AI is a powerful tool, but it is not infallible. It learns from the data we give it. If that data is biased, if it's incomplete, the AI's decisions can be flawed. One of the primary risks is the black box problem. Some models operate in ways not fully understandable to their creators. What if a decision seems optimal on paper, but puts the mission at higher risk in ways the AI wasn't trained to recognize? We must build systems that are transparent and explainable, so humans can question, understand, and ultimately override when necessary. Security is non-negotiable. A spacecraft's AI is vulnerable to cyber attack. Robust defenses are essential. We need global guidelines for AI in space. Humans must remain in the loop for critical decisions. Trust must be earned by rigorous testing, transparent operation, and ethical principles. Our ventures must be shielded from threats both physical and digital, creating a partnership where AI enhances human capability, not replaces human accountability. As we look toward the horizon, the future of AI-powered space exploration is dazzling with potential. The progress we are seeing today is just the beginning. We are on the cusp of missions not just assisted by AI, but fundamentally enabled by it. Imagine sending a swarm to Europa, landing, melting through miles of ice, releasing autonomous vehicles to explore the hidden ocean beneath. Soon, a global network of ground and space telescopes could be coordinated by a central AI. When a transient event occurs, the AI detects it and pivots the world's eyes instantly, capturing the first moments we currently miss. probes will become robotic scientists, forming hypotheses, running experiments, and sending back refined conclusions. As autonomy, efficiency, and resilience rise, costs and risks fall, opening space to more universities, companies, and nations. AI becomes a catalyst for a more inclusive era of exploration. More minds, more dreams, reaching for the stars. We stand at a remarkable moment in history. The quiet revolution is here. Artificial intelligence is already woven into the fabric of how we explore, making missions smarter, spacecraft more capable, and science faster. This is not a future to be feared, but a capability to be embraced with wisdom and excitement. We must test diligently, ensure safety, security, and alignment with our goals, demand transparency, and keep humans in the loop. Challenges aren't roadblocks, they're signposts to a sustainable space future. The next great discovery may be possible because an AI pointed us in the right direction. If you are inspired by smarter, faster, farther exploration, your journey of curiosity is just beginning. If you believe in a future where humanity and AI explore together, subscribe to stay connected with the latest breakthroughs. The stars are calling, and now we have a powerful new way to answer. What aspect of this AI-driven future excites you most? Smarter planning, smarter spacecraft, or smarter science? Tell us your thoughts in the comments below.